Welcome to our channel United Coaching. Today we will discuss top 20 questions from the topic carbon and its compounds, and this is the part 3 video. You can check out part 2 and part 1 video from our playlist, and this video contains previous year questions from boards like CBSE board, state board, ICSE board, and some of the national level exams as well. Okay, our first question is the correct electron dot structure of a water molecule is. So the correct option over here is C. In this one, as you can see, the oxygen has 8 electrons and both the hydrogens have 2 electrons. Now oxygen has atomic number 8, so its electronic configuration would be 2 and 6. That means the outermost shell has 6 electrons, and if it gains or shares 2 electron more, it will attain the complete octet, that is 2 and 8 electrons. Okay, and hydrogen has atomic number 1, so that means in the outer shell there is only 1 electron, and if it shares 1 electron or gains 1 electron, then the octet will be complete, that is 2 electrons. Okay, so this arrangement you can see only in the option number C. In option number A, you can see that the oxygen has only 6 electrons and both the hydrogen have only 1 electron each. Okay, so that is not the stable molecule. In option B, the oxygen has 7 electrons and both the hydrogens have, okay, one hydrogen has 1 electron and the first hydrogen has only 2 electrons. So this is also an unstable molecule. And in option number D, the oxygen has 4 electrons but both the hydrogens have 2 electrons each, so this is also unstable molecule in terms of oxygen. Okay, so only option C is a stable molecule because oxygen has 8 electrons and both the hydrogens have 2 electrons each. Okay, our next question is, which of the following are substitution reactions? Now, substitution reaction is when one atom is replaced by another atom or group of atoms. That is known as substitution reaction. So, in first option, you can see that there is ethene and hydrogen, and in presence of sunlight, it becomes ethane. So, that means the hydrogen is added. So, this is an addition reaction, not a substitution reaction. In option number B, the alcohol gets converted to a carboxylic acid, that is ethanol is converted to ethanoic acid. So this is an example of substitution reaction because the 2 hydrogens of ethanol are replaced by 1 oxygen. So this is also an example for oxidation reaction also and for substitution reaction also. Okay, and option number C, methane plus chlorine in presence of sunlight gives chloromethane plus HCl. So this is also a substitution reaction in which hydrogen is replaced by chlorine. Okay, and option number 4, there is ethyne, that is an alkyne, and the hydrogen gets added to it in presence of sunlight and it becomes ethene. So this is an addition reaction, not a substitution reaction. So the examples over here are B and C, the examples for substitution reaction. Okay, our next question is, first member of homologous series of ketones is. Now for a ketone, the carbonyl group has to be inside the hydrocarbon chain, because if it is at the end of the chain, then it will become an aldehyde. So when it is inside the chain, there has to be 1 carbon on each side of the carbonyl group. So that will make the propanol as the first member of the homologous series of ketone. Okay, our next question is, the name of the compound CH3, CH2, CHO is. Now as you can see, the CHO group, that is C double bond O and H, are the aldehyde group, and that is at the end of the chain, so that will make it an aldehyde. The carbonyl group is at the end of the hydrocarbon chain, so this will make it an aldehyde, and the suffix for an aldehyde is al, that is Al. So as this is a 3 carbon member, 3 carbon chain with an aldehyde group at the end, so this will make it a propanol. Okay, our next question is, the first member of alkyne homologous series is. Now for an alkyne, there has to be a 3 bond, that is a triple bond between 2 carbons. So the first member has to be a 2 carbon member with a triple bond between them. So as you can see, the answer is ethine. Okay, our next question is which compound has an addition reaction with chlorine? Now, only unsaturated compounds show addition reaction with chlorine. That is, unsaturated compounds like ethene or ethine with general formula CnH2n or CnH2n-2. Only they will show addition reaction with chlorine. So, as you can see in the given diagram, ethene reacts with chlorine and gives chloroethane. So, only option number 1 is correct, that is ethene. Rest of the options are saturated compounds, that is B is ethanol, C is ethane, that is CnH2n+2, and D is ethanoic acid. So all other options are saturated compounds. Only A is unsaturated, and that will show addition reaction with chlorine. Our next question is which of the following is not the property of homologous series? So option A, they differ by CH2 units. So this is true. B, they differ by 14 units by mass. This is true. Carbon has mass of 12 and hydrogen has mass of 1. So 2 each, that will make it 12 plus 2, that is 14 units by mass. Option C, they all contain double bonds. So this is not the property of every homologous series because alkane series doesn't have double bonds. And D, they can be represented by a general formula. So this is true for every homologous series, that every homologous series has their own general formula, like CnH2n+2 for alkane, CnH2n for alkene, and CnH2n-2 for alkyne. So they all have their own general formula. Okay, so the incorrect option over here is C, that they all contain double bonds. Okay, our next question is which of the following is correct for homologous series? So option A, melting point and boiling point increases with increasing molecular mass. So this is true. As number of carbon and hydrogen increases, the melting point and boiling point also increases from the as compared to the previous molecule. Okay. B, the difference in molecular mass between two successive members is 16 units. So this is wrong. The difference is of 14 units as we have seen earlier. And C, all succeeding members differ by CH2 units. So this is true. And C, that is C2H2, that is ethine, and C3H4, that is propyne, are not successive members of alkyne series. So this is incorrect. They are the successive members of alkyne series. So the correct options are A and C. Okay, our next question is correct formula for propanoic acid is. Now for propanoic acid there has to be 3 carbons, as the name suggests, propane. So there has to be 3 carbons, and oic acid is for carboxylic acid. So the structure has to have COOH bond, COOH group in the chain. So it has to be 3 carbon chain and with COOH bond. Group. So the correct option over here is C. As you can see from the given diagram, that is CH3, CH2, C double bond O and attached to OH group. So this whole group at the end is COOH group, that is carboxylic acid group. Okay, and it doesn't matter whether it's on the right side of the chain or left side of the chain. As far as this group is present in the chain, it will make it a carboxylic acid there. So as there are 3 carbons and a carboxylic acid group, so this will make it propanoic acid. So option number 3 is correct over here. Okay, our next question is when vegetable oil reacts with hydrogen, then it gets converted into vanaspati ghee, that is saturated fat. In this process, the catalyst used is, so the correct answer is D, that is nickel. As you can see from the given diagram, the unsaturated compound or hydrocarbon chain on the left hand side gets converted to a saturated hydrocarbon chain on the right hand side, and this happens in the presence of nickel as a catalyst, and the hydrogen gets added to the unsaturated compound. The double bond gets broken and gets converted to a single bond, and hydrogen gets added on the carbons which were having the double bond. Okay, so this happens in the presence of nickel as a catalyst. Okay, our next question is in the addition reaction of chlorine to methane in the presence of sunlight, what is the first product of the reaction? So as you can see from the given diagram, methane reacts with chlorine gas in the presence of sunlight and gives chloromethane plus HCl. So the correct option over here is B, that is CH3Cl plus HCl. Now this is an example of substitution reaction, and in this reaction in substitution reaction, one group of atom is replaced by another atom. Here chlorine replaces the hydrogen atom. Now saturated hydrocarbons are fairly unreactive and are inert to most reagents, but in the presence of sunlight, chlorine gets added to the hydrocarbon in a very fast reaction. Okay, so as you can see these three reactions on your screen. First is methane reacts with chlorine in the presence of sunlight and gives chloromethane and HCl, and this chloromethane further reacts with chlorine and keeps getting added. The chlorine keeps getting added to the hydrocarbon, and the final product is chloroform, that is CHCl3 plus HCl. Now this is a very fast reaction and it happens in the presence of sunlight. So there are multiple products in this chain of reaction, but the very first product is CH3Cl and the final product is CHCl3. Okay, so the correct option over here is the first product is CH3Cl and HCl. Now first option, that is methane plus H2SO4. So this is incorrect option, as we are not using sulfuric acid. We are using only chlorine gas in the presence of sunlight. Okay, so, and C option, CHCl3, that is chloroform itself plus HCl. Now this is the final product of this chain of reaction, so this is also incorrect for this question. And D option, that is CH3Cl plus H2SO4. So again H2SO4 is not used in the reaction, so this is the incorrect option. So the only correct option over here is CH3Cl, that is chloromethane plus HCl is the first product of this reaction. Okay, our next question is, what is the product of this reaction? So the given reaction is of alcohol and potassium dichromate, that is K2Cr2O7 is added, and that acts as an oxidizing agent, and H2SO4 is sulfuric acid, which provides acidic medium. So as K2Cr2O7, that is potassium dichromate, acts as an oxidizing agent, that means it adds oxygen to the compound. So the final product would be CH3COOH, that is ethanoic acid. Okay, so option number D over here is correct. Now option number A is methanol, that is an alcohol that has OH group, so that is methanol. And B is CH3, that is ethane, and that doesn't happen because it doesn't make it saturated compound and removes the hydroxyl group, the OH group, and makes it an alkane. Okay, it just K2Cr2O7 acts as an oxidizing agent, that means it just adds oxygen. Okay, and option number C, that is CH3CHO, so that is an aldehyde. Okay, so that also doesn't happen. It doesn't remove the hydrogen completely. Okay, it just replaces the two middle hydrogen. As you can see, CH3 and the middle hydrogen, the second carbon, two hydrogens attached to that gets replaced by oxygen. Okay, so this is a substitution reaction or oxidation reaction. So the correct option over here is D, that is CH3COOH, and that is ethanoic acid or acetic acid. Next question is, a carbon compound contains two atoms of carbon with a double bond. What name should be given? So now, as there are two carbon and between them there is two bonds, so obviously it is an alkene, and when there are two carbons then it is ethene. So the correct option over here is ethene. Yeah, next question is, vinegar, which is a diluted form of ethanoic acid, freezes during winter. What does this suggest about the physical properties of pure ethanoic acid? Now vinegar is the diluted form of ethanoic acid, around 5 to 8% solution, and pure ethanoic acid doesn't have water. Okay, so what does this suggest? That if the vinegar freezes in winter, then what does this suggest about pure ethanoic acid? Now vinegar freezes around 15-16 degrees Celsius in winter, and pure ethanoic acid freezes around 0 or -1 degree Celsius. Okay, so this means that it has a low melting point. That means around if it melts at -1 degree Celsius, that means around minus till -1 it is solid, and around -1 or 0 it is in liquid form. So it has a low melting point. Okay, now option A, it has a low boiling point. Now boiling point has nothing to do with freezing point. Okay, and option C, it has a very high boiling point. Again, boiling point has nothing to do with freezing point. And D, it has a very high melting point. Now this is wrong. If the melting point is high, let's say 500 degrees Celsius, so that means till 500 degrees Celsius it would be solid, and around that temperature it will when it reaches 500 degrees Celsius, then it will start melting. So that is not the case. If it is freezing at room temperature, and that is around 15-16 degrees Celsius, it freezes. That means around 15-16 degrees Celsius it will start turning into liquid, from solid to liquid and liquid to solid. This happens around 15-16 degrees Celsius for vinegar. And for pure ethanoic acid, it is around -1 degree Celsius. So around so at -1 or 0 it will be either in the solid state or melting state. It depends whether we are freezing it further or melting it further. So it can go in both the direction, either in the freezing point, turning into solid, or into the liquid. Okay, so what does this suggest? That it has a low melting point. Okay, our next question is methane, ethane and propane are said to form homologous series because all are hydrocarbons. Now that is not the criteria to belong to a homologous series. Hydrocarbons can be ethene and propene as well. So that doesn't mean that they belong to a homologous series. Okay, and B, saturated compounds. Now homologous series can be of saturated and unsaturated compounds as well. So that doesn't define a homologous series. And aliphatic compounds. Now what is aliphatic compounds? Aliphatic compounds are straight chain compounds. That means they are not cyclic compound like cyclohexane. Okay, so that also doesn't define a homologous series. And option D, differ from each other by CH2 group. So this is the only characteristic in this option, that to belong to a homologous series they have to differ by CH2 group. So the correct option over here is D. Our next question is soap solution results in micelle formation, which helps to remove dirt. What helps the oil and dirt to rise up? Now what happens inside the water? The molecules of soap have a unique orientation that keeps the hydrocarbon portion, that is the hydrophobic part of the soap, is out of the water. Okay, thus a cluster of molecule in which the hydrophobic tail, that is the hydrocarbon tail, are in the interior of the cluster, and the ionic end are on the surface of the cluster, that is outside the micelle and towards the water. So the ionic end is hydrophilic end, and this formation is called micelle. And the soap in the form of micelle is able to clean, since the oily dirt will be collected in the center of the micelle, and the micelle stays in solution as a colloid and will not come together to precipitate because of the ion-ion repulsion. Now option A over here, the suspension of dirt in the micelle. So this is correct option, that the dirt gets collected inside the micelle and gets out of the water. Okay, because what happens at the surface of the water in which there is dirt and soap, when the soap is at the surface of the water, the hydrophobic tail of the soap will not be soluble in the water, and the soap will align along the surface of the water with the ionic end in the water and the hydrocarbon tail protruding out of the water. So this helps the suspension, the oil and dirt, to rise up in the form of micelle as well, and along with the attachment to the hydrocarbon tail. The hydrocarbon tail is attached to the dirt, and because it is away from the water, so it helps the oil and dirt to rise up. Okay, option B, a collection of water molecule in the center of the micelle. So this is not true. Water is outside, not inside the micelle. And C, attraction between the ionic end and the dirt. So this is wrong. Ionic end is towards the water, and the non-ionic part, that is the hydrocarbon tail, which is hydrophobic, that is towards the dirt part. Okay, and D, mixing of soap molecule along with the dirt to make it heavier. So this doesn't happen, it doesn't make it heavier that it would settle down at the bottom of the bucket. So this doesn't happen. So over here option A is correct. The suspension of the dirt in the missile helps the oil and dirt to rise up. Okay, our next question is the functional group present in an alcohol molecule is. So is it carbonyl group? Now carbonyl is C double bond O, that is a carbonyl group, and carboxyl group is C double bond O, and on the other end it is OH attached to it, so that is COOH group, like in any of the carboxylic acid. C double OH is the carboxyl group, and carbonyl is like in a ketone, C double bond O, that is a carbonyl group. And hydroxyl group is the correct option over here, that is OH group is also known as hydroxyl group. So when this hydroxyl group is attached to a hydrocarbon chain, that it becomes an alcohol molecule. And alkyl is nothing but any of the alkane. When you remove one hydrogen from any of the alkane and make it attached to another hydrocarbon chain, so that alkane becomes an alkyl group. So alkyl group is nothing but any of the alkane, that is CH group. Okay, so the correct option over here is hydroxyl group, that is OH group. Okay, our next question is which of the following is an example of an ester? Option A, ethene. Now ethene is 2 carbon with double bond, ethane is 2 carbon with single bond, and ethanol is 2 carbon with a hydroxyl group at the end. And ethyl acetate is the correct option, it is an ester. Now as you can see from the figure, the red box is the ethyl part and the green box is the acetate part that comes from the acetic acid. Okay, and if you have any difficulty remembering the ester, you can use this trick that ester is very similar to carboxylic acid, that in the H in carboxylic acid is replaced by an alkyl group in an ester. So it is very similar to carboxylic acid, because what happens in ester, how ester is formed is when a carboxylic acid is made to join with an alcohol. So the hydroxyl group in the alcohol that loses the H, and the OH in the carboxylic acid is lost, and the carbonyl group C double bond O is attached to the O of the alcohol, so that makes an ester. So ester comes from carboxylic acid and alcohol, and it to remember the structure, you can remember it as very similar to carboxylic acid, that the H is replaced by an alkyl group in an ester. Next question is vinegar is a solution of. So the correct option over here is 5 to 8% acetic acid in water. It is not acetic acid in alcohol or 50 to 60% acetic acid in alcohol. Alcohol is not the option, and it is not 50 to 60%, it is only 5 to 8% acetic acid in water. Okay, our last question is the structural formula of cyclohexane is. Now cyclohexane is a saturated hydrocarbon in a cyclic form. So the correct option over here is the third option, or the second from the second on the bottom left side. So that is a cyclohexane, and rest of the options have double bond, that means they are unsaturated hydrocarbons. Okay, so these were the top 20 questions of carbon and its compounds, and if you like our content, you can check out our other playlist, and if you like, you can subscribe to our channel. Thank you.